Hi, this is the first of several videos that I'll be recording that show how to connect a .NET application to a SQL Server database, and I'll be demonstrating how to do this using Windows Forms. Now, in a future class that I'll be teaching, I'll also be doing something similar, but I'll be using active server pages for web applications. But for this example, we'll be using Windows Forms. Also, in this example, we'll be using SQL Server as a data source, and I have everything configured on a laptop computer, so this single computer is acting both as a client and a server, and that works well for development work. Obviously, when the application is finished, if I want to make it available in a production environment, then I would be using a database server on a different machine. Application programs would be installed on other computers, and everything would be connected via some type of network structure. But for our purposes, we're going to look at everything as it's installed on this single computer. So I've drawn a diagram that shows the major component parts, and again, from the user standpoint, they're going to see the application program. The application program will ultimately be accessing data from a database, and in order to get the application program to talk to the database and perform whatever task is necessary, I'll need to use the classes that are available in the .NET framework known as ADO.NET. So this is an application program interface that provides me with a number of classes that will work with specific technologies. But if I know how to program using these classes, then it's very easy to switch from one technology to another. So if I know how to write programs that allow me to connect to a SQL Server database, read data from it, display it in a Windows Forms application, then should I need to do that with some other database technology, it's simply going to be a matter of selecting similar but different classes from the .NET class library, base class library, and then once those classes are instantiated, the objects will work the same way for all applications. So they'll provide the same properties and the same methods regardless of what technology I'm using. So to make this a little bit clearer, again, I'm going to be using SQL Server as my database management system, and in my program code I'm going to be using classes from the .NET system.data.SQL client namespace. So these are classes that are optimized for SQL Server. If I were using some other technology, I might instantiate classes from either the system.data.odbc namespace or the system.data.oladb namespace. So it depends on the kind of technology that I'm using as to where I access the classes from the .NET class library. So regardless of which namespace I access classes from, there are a fairly short list. There's a fairly short list of classes that I need to familiarize myself with. And these classes fall into two major categories: providers and data set. And so the provider classes are designed to allow the program to manage the data source and control the flow of data, whereas the data set category of classes are designed to provide a means to cache data on the client, in many cases disconnect from that data, make changes to the data, and then sync back up with the server, reconnect and sync back up with the database server and update records. And so data sets we'll look at in another video. These can be used with Windows Forms. It's essential really to use these with web applications because of the nature of the internet technology. But we're going to start out looking at the connection class as a provider. So this is something that we always have to use. So regardless of whether we're caching records or not, we're always going to have to provide an instance of a connection class to create the physical connection to the data source. Then if we're going to be reading the data, or if we're going to be doing some very simple update procedure and don't have to synchronize or deal with concurrency control, then the command class can be used to store the SQL or a reference to a stored procedure that stores the SQL. And then to simply read the data, we could use a data reader class. The data adapter class is a little bit more involved, and I'm not going to get into it with this video. We'll wait until we look at data sets. And this is really a provider that provides some functionality that allows the program to sync up with the data on the database server and, where necessary, implement concurrency control. All right, so let me begin by running a program that I've written, and then we'll come back to this diagram, talk about the objects that we're going to need in order to perform the task that's being done, and then we'll look at the program code and see how these classes are actually instantiated, configured, and executed. So as I switch over to this program, I have a number of forms that perform a variety of tasks that use a variety of different ADO.NET classes, but for our demonstration today, I'm just going to look at the data reader that is used with with SQL that is configured as a string on the client side, and a data reader that is associated with a stored procedure. So in both cases, these programs are simply going to either pass an SQL command or make reference to a stored procedure that contains an SQL command, have the SQL executed on the server, and then read the rows from the result set and display them on the client computer. So as I run this first program, once I transition to a different form, the data appears immediately on the screen. Okay, we'll take a look at how that is and why that is. And when I run this program, it will ask for some input, and when I then provide that input, it will return values and display them on the screen as well. And we'll take a look at what's actually going on under the hood here in a second. But in both cases, I am just reading data that results from executing SQL on the database server. And in both cases, I'm going to have to use a connection object. It will have to be configured so that it accesses a very specific database server and then a very specific database on that server, and provides the proper login credentials in order to gain access to the objects that it needs to use. In both cases, I'll be using a instance of a command class, and in one case I will create the command class so that it passes, when it's instantiated, it passes an SQL string to the database server, and in another instance I'll design the command class so that it is able to call up a stored procedure and pass an argument to a parameter within that stored procedure. And in both cases, I will be, after passing the SQL to the server, having it executed, I'll be reading from the result set one row at a time and having whatever that returned row of data is displayed in a list box. And in the programs that I'm going to demonstrate in this video, I will not be using a data adapter class, nor will I be using a data set. Okay, so how does all this work? Well, going back to my program, again, I will run it, and we're going to take a look at Form 5. Form 5 presents itself like this as soon as it's called up. And if I stop the program and look at the program code in Form 5, here's the interface, a list box, and that's all there is. That's the only control object, excluding the label here, but this is the only control object involved on the form. So if I double click on the open form, for those of you that are familiar with C# programming language in .NET, you'll notice that there is a particular method that it will access called the form load event. Okay, so this is a method that will execute automatically when the form's loaded in memory, and this method executes just before the user has access to the form. So if there are class level variables, or if there's program code that is being executed from the constructor, that will occur ahead of the form load event. But once the form load event executes, then the user has access to the form. So automatically, before the user ever sees the form, in the form load event, I'll be declaring some local variables, and I'll be using those variables to reference instances of ADO.NET classes, and particularly these will be classes of the provider category. So we saw that as a provider class, there is a connection object. Now, I need to back up just one quick second. Notice that I have a using statement, and I make reference to system.data.sql client. Okay, so I'm telling my program, be aware that I will be referencing classes in these various namespaces, and if I happen to reference a class, for instance the SQL connection class, then since you know about this namespace, I won't always have to refer to it as system.data.SQL connection. I can just simply say SQL connection. And likewise with SQL command, I can simply say SQL command because you know about this namespace already, system.data.SQL client. So this is just a way of simplifying the program code here, and when an attempt is made to access one of these classes, the namespace will be resolved through the using statements. All right, so I create a connection object, all right, and I'm doing this with a local variable, so its lifetime and scope is going to be limited to the method in which it's created, in which it's declared. And so I have a short-lived object called obj connection. I create a new instance of the SQL connection class, and I send to the constructor a very specific string. Okay, so here's a string literal where I tell it the location of the server, which is on the local machine in this case, and that would differ, you know, if it were referencing a installed SQL server on a network. I tell it the name of the database that I want to use on that server. In this case, it is HRSQL2, and I give it the credentials to log in under, and I'm logging in under the SA account, and in a production environment this would not be the best account to use. In fact, it would be a poor choice, but in my case, because I'm doing this on a development platform, I'm going to go ahead and use the SA account. And following that, so all I've done is I've configured an object at this point that can physically connect to a very specific database on a very specific database server, and then I create another object of the SQL command class variety. So I declare a variable I call obj as an object, obj command, and I create an instance of it and make a call to the constructor and pass two arguments. The first argument is going to be the SQL command that I want to have the database engine execute. So in this case, I provide a string that represents my SQL command. So if that string translates into a legitimate SQL command, it can be executed. And as a second argument, I pass the name of the connection that I want to execute the SQL through. And in this case, I'm creating an SQL command right on the client. And this SQL command could have been, you know, even more involved in this. It could have been customized by concatenating string put from control objects on the form if I wanted to. But in this case, it's just a static SQL command. Again, I create a command object, and then I create a variable of SQL data reader type, but I don't actually instantiate the data reader class. I'm going to do that in a different way in a subsequent statement, but I have a variable that I can at some point then use to reference my data reader object. So I set things up with the variables that I intend to use as objects in my program code, and then execute the open method on the connection object. So again, it's an object. It has a number of methods and properties. So it has a open method which will create the connection to the data source. And then I execute the execute reader method on the command object. Okay, so the command object again is the one that is configured with an SQL command when it's instantiated. I execute the execute reader method, which will tell the database engine to execute the SQL, and it will then return an object and assign it to this variable. So at this point, OBJReader is an object, and I can invoke its methods and use its various properties. And so at this point, when I reach the while statement, OBJReader is an object, and I can make use of its return type read method. Okay, so I emphasize this is a return type method. It's going to return a bool, and it will, when executed, retrieve the current row of data in the result set. So I'd mentioned, I think in class when I did this, that the data reader is like a fast forward cursor on the client side. It stores one row, so it's going to return the current row from the result set on the server, and if it's successful in fetching that row, it will return a true value to the while statement, and if it has read beyond the bounds of the result set, if it's read past the last row in the result set, an attempt to read will return a false, which will kick me out of the loop. So I'm assuming first time through, a successful read, and at that point I'm going to be using the data reader's column collection and concatenating a long string and adding it to the list box items that are displayed, or the list that appears in the list box. So for those of you that are programmed in C# and .NET programming languages, you know that there is an add method that's used with the items collection of certain controls like list box, and that's how you insert an item into the list. And so what item am I inserting into a list? Well, the add method requires that whatever is inserted be of string data type. So I'm going to insert the column values from the current row in the data reader, and if I look up at the result, at the command object, you'll notice that when it was instantiated, I executed a select statement, and in that select statement I project a last name column, an employee first name column, and a dependent first name column. Okay, so there's 3 columns that are being projected. Those columns are going to be inserted into the data reader, and therefore there are 3 columns in the data reader. The first column is going to be storing whatever that current row in the result set is, the employee last name, and the second column is going to be storing the corresponding employee's first name, and the third column is going to be storing the corresponding dependent's first name. And in the course of putting this all together, I'm doing string concatenation, and I'm taking the values that are returned to the columns in the reader, converting them to string, padding them with some trailing spaces, and doing the string concatenation in order to create a new row of data that displays 3 columns from the result set. And once it has populated the list box, then control passes to the while statement, where another read is attempted. If successful, it populates the data reader with a new row of data from the result set, and it also returns a true value to the while so that that row can be concatenated and inserted into a list box. And that continues on and on until eventually I've exhausted all the records in the results set. One final read will be attempted beyond the bounds of the results set and return a false, at which point the while statement will end and control will pass to the statement immediately beyond that while block, and I'll execute a close method on the connection object. Okay, and again I make note that if I left that out it wouldn't be all that bad because I'm using local variables, but good idea to go ahead and close that connection, and at that point the program's done. And the whole thing is wrapped up in try catch, so if something fails along the way it's going to jump to the catch block, and in this case I just set it, I didn't do anything with it, so it's not programmed out real thoroughly, but nevertheless if I wanted to take the time to develop the catch block I could have. Alright, so hopefully that makes sense, and that is the program code that allows this to happen. Now what we're going to look at is the program code here. So again, if you remember when I use this form, I'm expected to provide some input value and then click the button here to cause whatever the task is to execute. Alright, so how's this working? This is Form 3, so I'll take a look at Form 3. This is going to use a stored procedure, and in fact I think I will switch over to that stored procedure right now. I have a copy of it in a text file here, so we can take a look and see that the stored procedure has a single parameter of integer data type. It is pretty straightforward, performs an inner join between two tables, and then selects records from that result set where a field value is equal to the input parameter value. Okay, so simple enough to comprehend. And if I run the program one last time, I provide for that single parameter value and get this result. So let's see what's happening under the hood on Form 3. So in Form 3, when I double click on the open form, you'll notice that I don't have any program code in the form load event, okay, and that explains why nothing happened until I provided input to the text box and then click the button. So if I click the button and bring up the code window, it takes me to that click event method, and it doesn't look all that significant, okay, and the reason for that is because I broke this task down into a couple or three different private methods. And so the first thing that happens in the button click event method is that it checks the length of the input in text box 1, and if it's greater than 0, that means the user didn't click the button out of sequence but actually responded to things in the proper order by populating the list box and then clicking the button. And if it takes that preferred path, it's going to then convert whatever's in the text box to integer data type, which happens to be the data type that is required of the stored procedure parameter. And then it's going to call up a method called build and display, and after it's done with that, it's going to disable the button. Okay, so if it finds that the length of the text box is not greater than 0, that means the user didn't respond to things in the proper order on the form. It's just going to fire off a message box and refocus on the text box. And of course, everything is wrapped up in try-catch, so that if the user responds to the text box and clicks, but what's been inserted cannot convert to integer, then it'll take the catch path and correct things. All right, so assuming that it takes the if path and it is successful in converting the input, then it's going to call up a private void type method called build and display. So somewhere I have this method called build and display. I pass it the converted input value, and it's this method that contains all the code necessary to perform the task. And what is that code? Well, it's code that's going to be executed using the same provider classes that we looked at in the last example. The connection is going to be to the same database on the same server, and it's going to log in under the same credentials, so that is exactly the same line of code that we saw in the previous example. The command object, which will, in this case, allow me to execute a stored procedure. So in the previous example, when I instantiated the command class, okay, trying to move this around here. So when I instantiated the command class before, I passed 2 arguments to the constructor, the first being a string that represented an SQL command, and the second argument being the reference to the connection object. Notice that when I instantiate the command object this time, I don't pass anything to the constructor. Then I also create a variable that's going to be used as my data reader, and the way the data reader works here is going to be the same as it did before. So in the next part of this, I have to deal with the SQL part, getting the SQL set up for the database engine. But I'm not going to pass it an SQL string. Instead, what I'm going to do is configure properties of the command object. So I'm going to, instead of passing the name of the connection object to the constructor, I'm going to assign it to a connection property. And then I have a command text property, and I'm going to assign it the name of the stored procedure. So that has to be written exactly like the stored procedure is named on the server. And I have to tell it stored procedure by way of command type. And then I have a parameter collection, and I can add to that collection using the add with value method. And that add with value method requires 2 arguments, one being a string that represents the name of the parameter that's used in the stored procedure on the server. Okay, so that needs to be coded exactly like the parameter name, and it's case sensitive, I believe. At least I would code it that way, pretend that it is. And then I also have to provide it the actual argument, which the actual argument in this case is the parameter that is part of the method which was called up. Now, if I have multiple parameters, I would just repeat this, again and again and again, configuring it for each of the parameters, that additional parameters in the stored procedure. This stored procedure just has 1, so therefore I only have 1 statement of this variety. Now at this point, the command object is configured, okay, configured again through assigning to property values rather than configuring it through the constructor. I execute the open method on the connection object, same thing that I did before, okay, and really logically at the same location. So before I declared, you know, the variables and instantiated 2 of them, and then, you know, configured the connection string through the constructor, and before I opened the connection I had, because of the way I instantiated the command class, I had the command class configured. So now that my command class is configured, I open the connection and I execute the execute reader method on the command object, and this time it tells the database engine to run the stored procedure and execute the code in it. And it will return then a object, and at this point OBJ reader is instantiated and I can begin making references to its properties and methods. And so I drop into a loop, and this is exactly the same thing that I saw before. It's simply taking the result set, which was executed by way of the stored procedure, and row by row it returns a single row back to the client. The row columns are concatenated and added to the items collection of the list box. It does that over and over again until finally it hits the end of the result set, at which point the read method returns a false and kicks out of the while loop. And at this point I chose to comment out the close just to show you that what I had said previously does in fact work. And I also, in this example then, and this is more of a C#.NET thing than it is anything else, but I passed the system exception object to the catch path, and I'm able to then display through a message box any error that occurs if the catch path is taken. So .NET maintains this exception object, and I can look at the messages that the system returns in the event that an error occurs. So that can be useful, and I don't know whether I ever demonstrated that before in CPSC 1500. May have, but there are people that haven't taken CPSC 1500 that are taking this class, so you might play around with this. It's very useful, and especially in database programming where there's the potential of not getting the connection string configured quite right, or any number of other things that might happen on the server. So you might find that useful. Well, I think that concludes everything that you need to know about the first 2 forms that are used in this application. And again, just as a quick review, I have a Windows Forms application. I'm accessing a SQL Server database, so the using statement that I provided looks like the top using statement here, and that tells the system that anytime I reference a class to go, look in that namespace, resolve the name of the class through that namespace. I've used the connection class, and always we have to use that, always. And given what I was attempting to do, that is execute some SQL and read the result set back to the client and just display it in some control, I used a command class and I used a data reader. And the way I used the data reader was standard in both applications. The only thing that was different really between the two applications was that in the first example, I configured the command class to execute, to pass a SQL string to the database engine to have executed. And in the second example, I configured the command class so that it would be able to pass the name of a stored procedure and a parameter value to the database engine so that the SQL could be executed through the stored procedure. And that is everything that was necessary to get my application program to read data from a SQL Server data source.